Hello and welcome to GeoEd with Abhisek. In the last class, we have studied about the combination of rotational symmetry and reflection symmetry. In today's class, we are going to talk about roto-inversion, which is the combination of rotation and inversion. So rotation means rotational axis of symmetry, and inversion, which is the center of symmetry or inversion through the center. Okay, so either way we can go. Either we'll go for rotation, then we'll go to inversion, or we'll do the opposite, inversion, then we'll come back to rotation. Here we will represent the symbols with rotation symmetry like 1, 2, 3, 4 like that, along with a bar. 1 is rotation axis. When we put bar above it, that means it is rotation plus inversion. So only 2 will represent two-fold rotation axis. But when we put bar above 2, it will become two-fold rotation plus inversion. Similarly, only 3 or 4, they will represent three-fold or four-fold rotation axis. If we'll put bar above them, it will represent roto-inversion symmetry. Three-fold rotation plus inversion. Similarly, four-fold rotation and then inversion. So we'll start with 1 bar, then we'll go to 2, 3, 4 and 6. So in 1 bar, what will happen? This is the rotation axis. This axis is the rotation axis. Now this is a face. Suppose F1 is the face. Now we will rotate and then invert. As I told, either we can go rotation then inversion, or we can do inversion then rotation. So first we will do rotation, then we will do inversion. One fold rotation, what does it mean? 1 bar means one fold rotation plus inversion. What is the meaning of one fold rotation? Means in 360 degree we will have only one face. We will have only one face. There is no symmetric face in 360 degree. Okay, like in the first class we have studied, one represents pedial class or pedian. Pedian means single face. Pedian means single face, which is represented by the symbol 1. This is belongs to triclinic system. In the triclinic system, we have this class which is represented with the symbol 1, means one fold rotation, which means in 360 degree only one face is there. So this single face class is called pedial class. The form is called pedian. Okay. Now 1 bar. 1 bar means one fold rotation, then inversion. In 360 degree, we will get one single face. This is the same face we will get in 360 degree rotation, and then we will invert through the center. What is inversion? What is rotation? How we will represent? See the cap. This is the yellow side. This cap's yellow side. Now I am rotating it. This is rotation. This is rotation. So what we have to do is we have to rotate 360 degree, because it is one fold rotation. We have to rotate 360 degree. From original position we will start and we will rotate 360 degree. That means we will come back to the same position and then we will invert. This is how we will invert. Through the center we will invert. Again I will repeat this. This is the initial position. What we have to do is one fold rotation means 360 degree, one single face. That means after 360 degree we will come back to the same face. There is no other face in the 360 degree rotation. So we'll start from here, 360 degree rotation and then inversion. This is the inversion. Okay, here this is the initial phase F1. We have to rotate it 360 degree. In 360 degree we will not get any other face. This is the only one face, and then we will invert. When we will invert, we will get another symmetric face. Now this is the symmetric face which is inverted through the center. Okay, so although they are appearing like same face, They are appearing like mirror images because in this slide we have taken rectangular faces. So they are appearing like there is a mirror plane here. But it is not a mirror plane. It is inverted through the center. How you can better understand? Let's take like this. Let's take the face as this. If this is the face. Then after roto-inversion, after rotation, it will come to the initial position and then we have to invert. So if we will invert, how it will become? It will become like this. If you remember in the first class I have told you, inversion means the top will become bottom, the right will become left. Okay. Similarly here you see the top face came to bottom, the left side becomes right side. The front side, suppose this is the front side, it became back side here. Top becomes bottom, front becomes back, left becomes right. This is how inversion works. In reflection, we just have to change the right left orientation. Right will become left, left will become right. That is what reflection does. But in inversion, everything will change. Top will become bottom, this left will become right, and front will become back. Okay, you see part, this part, it is in the top region, in the front side towards the left. Now it became in the bottom towards the right and in the back side. This is how inversion works. So now if you see these two faces, now if you compare these two faces, they are not mirror images, right? They are not looking like mirror image. Can you place a mirror image here in between? No, this is wrong. Okay, so roto-inversion symmetry or inversion symmetry is not equal to mirror plane. One bar will not be equal to mirror plane. When it is one fold rotation and inversion, it will not become mirror, rather it will become center of symmetry. Everything is inverted through the center. Okay, so this is represented as I. One bar is also represented as I, which is representing center of symmetry. Okay, yes, this one bar belongs to which system? Again, triclinic system. And here there are two faces which are parallel. These are two faces which are parallel, but there is no mirror plane. These two faces are parallel, but there is no mirror plane. Why there is no mirror plane? Just I have shown, if this is the side, this side will come here. After inversion, this side will come here. If it is reflection, it has to come here. If there is a reflection, if there is a mirror plane, the line should repeat at this position. But it is not the case here. What happens is the line is inverted. The line from here will come to this position. So it is inverted through the center. Through the center, it has to invert. Then we will call it inversion. If this is the center, this line inverted through the center. Okay, so when there are two faces, like as I told, in one fold symmetry, if there is one face, then we'll call it pedion. If there are two faces which are related with center of symmetry in between, we will call it pinacoid. Remember this. If there are two parallel faces which are related to each other by a center of symmetry, they are called pinacoid. This pinacoidal class is represented by one bar and it will come in triclinic system as well. Okay, so 1 and 1 bar both are belonging to triclinic system. One represent pedial class and 1 bar represent pinacoidal class. So we'll go to the next one, 2 bar. What is the meaning of 2 bar? means twofold rotation plus inversion. What is the meaning of twofold rotation? Means 360 degree we will get two faces. In 360 degree we will get two faces. That means in each 180 degree we will get one symmetric face. In 180 degree rotation we will get one symmetric face. Okay. So this is the rotation axis in between, and this rotation axis is represented with two bar symmetry. When it is twofold, we will represent in ellipse. When it is fourfold, we will represent in square. When it is threefold, we will represent in triangle. When it is sixfold, we will represent in hexagon. And when it is 2 bar, 3 bar, 4 bar, like that, then what we have to do is we have to make a circle in between. That means it is reduced or inversion is there. Okay, when it is having a circle inside or open circle inside, then it is 1 bar, 2 bar, this is 4 bar, this is 3 bar, and this is 6 bar. Okay, so this is the rotation axis, twofold rotation axis plus inversion will be there. Okay, so this is the first phase F1. What we have to do is we have to rotate 180 degree, as in 360 degree we have to repeat. So after 180 degree rotation we'll get F2, which is the second phase. But this is not the final phase. After 180 degree we should get phase here if it is only twofold. Let's say I'll put it F2 dash. Why it is not F2? Because our second phase will come after rotation plus inversion. Our symmetry is not rotation. If we have only twofold, suppose we have this symmetry, one axis of twofold, then if this is F1, if this is the first phase, its symmetric phase will come here. This will become F2. But we are now doing roto-inversion. Means after rotation what phase will come is not the final one. We have to invert it again. That means this phase, what you are seeing here, this is not the symmetric phase, or this is not the final phase. What we have to do is we have to invert it. In the next step you can see this is the F2. This one is F1, the initial phase. What we have done is we have rotated and then inverted. This rotation phase is not required for us. This rotation phase is not our final phase. Our final phase should include both rotation and inversion. Is it clear? Hopefully it will be clear. Then I'll repeat it again also. So this is the first phase, original phase. As we have twofold roto-inversion, first we have to rotate 180 degree. Twofold rotation means 180 degree rotation and then inversion. And then inversion. Because we have bar, because we have inversion, the phase has to invert. Without inversion, we cannot take it as a final phase, or we cannot consider it as a symmetric phase. This is twofold rotation and then inversion. The phase which will form here will become the symmetric phase F2. Okay. Now what to do? If you have marked from the first class how we are doing this symmetry operation, we will take one face or motif. Suppose we'll take this face as a motif and we are trying to find rotational symmetry. We are trying to find rotational symmetry. What we have to do is we have to start from a face. Suppose this is our initial face or initial motif. From here we'll start. After 90 degree rotation we found one, another 90 degree we found one, another 90 degree we found one, and in the next 90 degree we came back to the original one. That means our rotation symmetry, or our finding of symmetric faces, which are related to rotation axis, that ends here when we came back to the initial position. We started from here, which is having this orange center. Okay, we started from this phase and then we started rotating. Second phase came, third phase came, fourth phase came, and then we came back to the original phase. When we reach our original position, then only the symmetry operation will stop. What is the operation here? What I am doing? I am rotating. So rotation is the operation. What is the element? The axis is the element. The rotation axis is the element. Okay. So we start from this phase and we rotate. We are continuing our operation to find the symmetric phases. We are continuing our operation to find another symmetric phase. Then when we reach the original position or the initial position, at that position we have to stop our operation. Rotational operation will end here when we reach our the first phase, when we reach the first phase or the original phase. Okay. Similarly, here we started with F1, we rotated, then we inverted, we reach F2, we reach F2. We cannot stop our this operation, roto-inversion operation, we cannot stop here because we have to reach the initial phase. When we will reach the initial phase, then only we will stop the operation. Now what we have to do is we have to repeat the step again. What we have to do, suppose we started with this, what we have done is we have rotated. Is this the original phase from where we have started? No, this is another phase what we got. This is a symmetric phase which we got after 90-degree rotation. We started from here, after 90-degree rotation we found a phase. Can we stop our mission here? Can we stop our rotation here or the operation here? No. What we have to do is we have to rotate it again. Now we found second phase. Can we stop here? Can we stop our operation here? No. This is not the original phase. So what we have to do is we have to rotate it again. We found another phase. Can we stop our operation here? No. We have to go to our initial position. So we will rotate it again. So we reach the initial position. Now this is the end of our operation. So through this operation, through this rotation, we found 4 symmetric phase. Then we represent that this axis is having 4-fold rotational symmetry. Okay. Similarly, here if we will stop at F2, then that is not the completion of operation. Here we cannot complete. What we have to do is we have to rotate it again and then invert it. If it is coming to the initial position, then it is the end of the operation. Understood? We started from F1, then we rotated. As it is roto-inversion, we cannot stop here, we have to invert. Now this is F2, our symmetric phase. Then this is not the initial phase. What we have to do is we have to go to the initial phase. Now again we will rotate. Again 2 bar means 180-degree rotation. 2 bar means 2 phases in 360-degree. So 180-degree rotation we have to get another phase, but which we will not get here because we are having bar above 2, means we are having inversion. So we will rotate it and then invert it. So now we reached F1. So now we can conclude that we are having only 2 phases. Here this is F1, here this is F2, and we are not getting any other phases. Neither we are getting this phase nor we are getting this phase. These are not the symmetric phases. These 2 phases are not symmetric because we are having rotation plus inversion. We cannot consider the phase what we obtained through rotation. We cannot select those phases which we have obtained through rotation. What we have to consider is rotation plus inversion. So this one is the first phase, this one is the second phase. If we again do the operation from F2, rotate and then invert, then we will come back to the original phase. So now we can say our mission stopped here, or our operation stopped here. We have two phases, and these two phases are one above other. You can see F1 and F2, they are one above other, means F1 is above F2. And we can see that there is a mirror plane. There can be a mirror plane. There is a possibility of one mirror plane here in between. Okay, these two faces F1 and F2, they will become mirror image. As these faces are one above other, they are looking like mirror image. Now here also, if you take this, like instead of rectangle, if you will do this, you can try this one on your own, you will get such face. Now this is not inversion, this is reflection. In one bar, what we obtained, in one bar, if you will do this, you will get that sign here, because it will invert. Okay, because this will invert. But here, if you see in twofold rotation and inversion, they will become reflection. They will become reflection. So that's why 2 bar is considered as mirror plane. That's why 2 bar is considered as a mirror plane. 2 bar equals to M. Okay. So instead of 2 bar, we can write M. In monoclinic system, we have three classes: 2, 2 bar and 2 by M. This 2 bar is otherwise known as M. So we have 2, 1 class, M, 1 class, and 2 by M, another class. So here, these two faces, when we have taken 2 bar, when there are two faces, F1 and F2, when they are related by one mirror plane in between, when they are related by one mirror plane in between, when there are two parallel faces, in the last example we have seen, when it is 1 bar, there are two parallel faces. When there are two parallel faces related by a center of symmetry, we call them pinacoid. We call them pinacoid. For 1 bar, it is pinacoid because the two faces are related to center of symmetry, related to each other by center of symmetry. Here two faces are there which are related to each other by a mirror plane in between. These faces are called dome. This structure is called dome. So in the monoclinic system, when we have this M, and we have this class M, this is called domal class, or dome is the form and class name is domal class. So M stands for domal class, which will come in monoclinic system. I hope it is clear. Now we'll go to the next example. This is 3 bar. 3 bar means threefold rotation, one axis of threefold rotation plus inversion. Okay, this is very important class. It will come in your trigonal system. Okay, here we have the threefold rotation and inversion axis, roto-inversion axis. Here it is a triangle representing threefold rotation, and there is a circle in between the triangle, so it means inversion also, means rotation plus inversion. So we'll start with one face here. This is our F1. So we'll start with this phase. Now what is threefold rotation? Means in 360-degree rotation we have to get three phases. That means after each 120-degree we should get another symmetric phase. After 120-degree rotation we should get another symmetric phase. Okay. So now this is the first phase F1. After 120-degree it will come here, but it will not be our final phase. It will not be our symmetric phase. Why it will not be the symmetric phase? Because this is the rotation phase. This position is giving us rotation phase. So this can be F2 dash, but it cannot be F2. Why it cannot be F2? Because it is rotation phase. What we have to find is rotation plus inversion. What we have to find is roto-inversion phase. So from here we have to invert again through the center. Through the center we have to invert it. So it will come here. This is the F2. This is the F1, the blue one, and F2 is the pink one. So what we have done is we have rotated 120 degree because it is threefold, means after 120 degree we should get another phase. Then we have inverted it through the center, so it became F2 here. Now can we stop the mission here? Can we stop the operation here? No. What we have to do is we have to again rotate and invert. So from the second phase again we will do rotation. It will come here. Rotation phase will come here. This is F3 dash. It is F2. This is F1. After rotation, again after 120 degree rotation, it will come here F3 dash. Now what we have to do? We cannot take the rotation phase. This is the rotation phase F3 dash. But we cannot take rotation phase. We have to take inversion. We have to invert it. So this phase will become our F3. This phase will become F3. This yellow one will become F3. So this phase F1, this pink one F2, and this yellow one F3, third phase. Okay. So now can we stop here? This is 1, 2 and 3. Can we stop our operation here? No, because third is not the original phase. This one is not the original phase. We have to reach the original, then only we can stop the mission. So from third again what we have to do is we have to rotate 120 degree and then invert. So if we will rotate 3, it will come to 1. If we will rotate 3, it will come to 1. If we will rotate 3 by 120 degree, it will come to 1. But there we cannot stop the mission because rotation is not our final phase. Our final phase is rotation plus inversion. So here we'll get F4 dash, not F4. We'll get F4 dash. Then what we have to do is we have to invert it through the center. We have to invert it through the center, so it will reach this place. This will become our fourth phase. This will become fourth place. Okay, this violet one will become our fourth place. Okay, I hope everybody is getting. I will repeat it again once we will complete all the phases. So now this is the F4, the fourth phase. Now what we have to do? Is it the original one? No, this is not the original one. We started from here, F1. So we have to reach F1. So till we have not reached F1, we have to repeat the operation. We have to rotate and invert. We have to rotate and invert until we get phase number 1, the initial phase. So if we will rotate the phase number 4, which is at the bottom side, this is the phase number 4, which is at the bottom side of the, which is in the lower hemisphere. If we consider it as a sphere, this fourth phase is in the lower hemisphere. Now if we will rotate it 120 degree, if we will rotate the fourth phase 120 degree, it will come here to the position of phase number 2. The fourth phase, if we will rotate, you imagine this fourth phase is in the lower hemisphere. This 1 and 3, they are in the upper hemisphere. If this is a sphere, 1 is here, 3 is here, 4 is here somewhat, and 2 is here. So if we will rotate 4, it will come to 2. It will not go to 3 or 1. It will come to 2. 4 is in the lower hemisphere, in the lower hemisphere. So rotation will be in same hemisphere. If I am rotating this pen, if I am rotating only, the cap is rotating in the upper hemisphere. The bottom part of the pen is rotating in the lower hemisphere. the cap is not coming down. Okay, in rotation we have to rotate like this. In the same hemisphere we have to rotate. In inversion we have to change the hemisphere. In inversion we have to change the hemisphere. So if we'll rotate for 120 degree, it will come to the position of second phase. Okay, this is our F5 dash. This is our F5 dash. This is the rotation phase. Then what we have to do is we have to invert. So it will come here. It will come here. This will become our F5. This will become our fifth phase. This is the first one. This is the second. Then here there is the third. This is the fourth. And this is the fifth. Now can we stop here? 5 came to upper hemisphere. 4 was in the lower hemisphere. It rotated and then inverted. Okay. Now 5 will rotate 120 and then invert. Rotation means same hemisphere. Inversion means opposite hemisphere. So 5 will rotate. Because we have not reached the initial phase, we have to rotate it again. So 5 will rotate 120 degree. It will come to this yellow phase, which is the third phase. It will come to that position and then we have to invert it. So it will come back to this position. It will come back to this position. 6. 5 will rotate. This is the F6 dash and then we will invert. So it will come here. This is the sixth phase. Now 6 is in the lower hemisphere. 5 was in the upper hemisphere, rotated and then inverted. It came to lower hemisphere. Now 6 will rotate because it is not the initial phase. 6 is not the initial phase. What we have to do is we have to rotate it again. So it will go back to the fourth phase, this violet one. If we will rotate F6, which is here, if we rotate it, it will go back to the fourth one, violet phase, and then if we will invert, it will go to the first phase. If we will rotate 6 by 120 degree, it will go this back side and lower hemisphere, the fourth phase. In this position there is a phase, so it will go to that phase and then it will invert. It will invert to reach the F1. It will reach F1. So now F1 is our original phase. So we can stop the mission here. We can stop the mission here. So now we can again go back and see what happened in 3 bar. So here this is our F1, the first phase. So what we have to do is rotate by 120 and then invert. So we have rotated, we got F2 dash and then we inverted, we got F2. This is our second phase. Now what we have to do is again rotate by 120 and then invert. We have to rotate and invert. So that's how we got F3. This is F1, this is F2 and this yellow one will become F3. Now again that we have to rotate and invert. We have rotated 3, it will come to 1, then we have to invert it, it will come to 4. Now 4, if we will rotate, it will come to 2. If we will rotate 4, it will come to 2 and then we have to invert, so it will come to 5. Now 5, if we will rotate, it will come to 3. If we will rotate 5, it will come to 3 and then invert, it will come here to 6. Now if we will rotate 6, it will go to 4 and if we will invert, it will go back to 1. So we reach the initial position. We can stop our mission here. We can stop our operation here. So we got these 6 phases. Now you can see the clear picture. This is the first one, F1, rotated, inverted. This is the second one, then rotated and inverted. We got the third one. Third we rotate and invert, we got fourth. Fourth we rotate and invert, we got fifth. Fifth we rotate and invert, we got 6. Okay. So this class is rhombohedral class. As each face is a rhombus, it is rhombohedral class. You remember this is very important. Why? Because it is the class of calcite. Calcite forms in this class, rhombohedral. If you have studied in optical mineralogy, calcite is used in nickel prism as a polarizer. As a polarizer, you use calcite. In nickel prism, we use calcite because of its rhombohedral shape. Okay, so rhombohedral class comes under trigonal system, which is a subclass of hexagonal system, and its symbol is 3 bar. Its symbol is 3 bar. So 3 bar gave us 6 faces. 3 bar gave us 6 faces. If you remember, in 1 bar we got 2 faces. 1 bar we got 2 faces. So I named it pinacoid. Now here 3 bar we got 6 faces. So you remember, whenever we put bar over odd numbers like 1 and 3, whenever we put bar over odd numbers like 1 and 3, the number of faces will be doubled. The number of faces will be doubled. If it is 3 alone, then we should have 3 faces because it is a rotation symmetry. We should have 3 faces if it is 3 alone. But when we put 3 bar, we will get 6 face. If it is 1 alone, we will get the one face, that is the pedian or pedial class. But when it is 1 bar, we got 2 faces. It becomes pinacoid. Okay, so whenever we put bar over the odd number, it will become, the number of faces will become double. Then we will go to our next class, which is 4 bar. So 4 bar means 4-fold rotation plus inversion, one axis of 4-fold rotation plus inversion. So we have 360, we have 4 faces in 360-degree rotation. That means after each 90-degree we will get one rotational phase, but we have to invert it again. Rotation phase is not the final phase because we are considering roto-inversion. We have to invert after rotation, then we will go to the final phase. Okay, so this is the first one, F1. What we have to do is rotate 90-degree. It will come here. This is F2 dash. This is not the final phase. This is the transition. This is the transition. From F1 we rotated 90-degree. Then what we have to do is we have to invert it. We have to invert means from up. This is now in upper hemisphere. Now we have to take it to lower hemisphere. That's what inversion is. So from here we have to invert it. So it will go to this place. This is our F2. This one is F1. We rotated and then inverted. Now we will rotate F2 again because F2 is not the initial phase. F2 is not the phase from where we have started. So we have to rotate and then invert. F2 we will rotate and then we will invert. If we will rotate F2, this is F3 dash. F2 is the pink one. We rotated, it came here. Then it will invert, it will reach this position. Now this is our F3. This is first, this pink one is second, and this orange becomes third. Now what we have to do? Again we have to rotate and then invert. The third we will rotate, it will come here, you see. This is the rotation phase, and then we will invert, it will come here. This is the fourth one. This is F4 dash and this is F4. Rotation phase is not the final, we have to invert it, then it will become final. Okay, so 1, then 2, and then 3, and then 4. Now what we have to do is, again we have to rotate, it will come here, and we have to invert. Rotate and then we will invert. when we will rotate and invert, when we will rotate the fourth phase and invert, it will reach the initial one. It will reach the first phase. It will reach F1, the original phase from where we have started. So we have to stop our operation. Because we have reached the original point, original phase, we have to stop the mission. Okay, so this is 1, this is 2, this is 3, and this is 4. When we rotate 4 and invert, it will reach 1, so we have to stop the mission here. So now we have two phases above and two phases below. Two phases in the upper hemisphere and two phases in the lower hemisphere, and both of them are related to one two-fold rotation axis. So one two-fold axis is there and two faces are there. In the upper hemisphere two faces are there, in the lower hemisphere two faces are there. Okay, so when a crystal will be formed, there will be no open spaces. You see there is few open spaces. This is first phase, this is second phase, this third phase and fourth phase. So we have open spaces here, we have open spaces here, we have open spaces here. So when we form a crystal, they cannot be opened, right? Crystal means it is closed, it will have definite shape, definite internal structure, definite outer appearance. Okay, so it will not be like this. It cannot be, it cannot remain open in some side. It has to be closed in all sides. Okay, so it will become like this. This is first phase, third phase, second phase, and fourth phase. So above there are two phases with a two-fold axis in between like this. This is the two-fold axis, and there are two faces. And below there are two faces like this. Like this. The above faces are like this, and the lower faces are like this. So that's how we can close the crystal. We can form a closed crystal. These are the upper two faces, and these are the lower two faces. Okay, and in between we have a two-fold rotation axis. In between we have a two-fold rotation axis. When we talked about one bar, I told when two faces related to, when two faces are present related to each other by center of symmetry, then they are called pinacoid. Then they are called pinacoid. Then I told two bar, when two faces are related by mirror. If you remember two bar, I told in the two bar, the two faces they are related by a mirror plane in between. Then we will call it dome. When there are two faces related by a two-fold axis, when there are two faces related by a two-fold axis in between, we will call it sphenoid. Remember this. Okay, when there are two faces related by center of symmetry, they are called pinacoid. When there are two faces related by mirror plane, it is called dome. When there are two faces related by two-fold axis in between, it is called a sphenoid. So here we have two faces above, and in between them there is a two-fold axis, and two faces below, and there is a two-fold axis in between. Above two faces, two-fold axis, below two faces, two-fold axis. So now above there is a sphenoid, below there is a sphenoid, so it is a disphenoid. That's why this class is called disphenoidal class. 4 bar will come in tetragonal system. It will come in tetragonal system. One axis of four-fold symmetry. It will come in tetragonal system, and it is disphenoid. It will be named as disphenoidal class. Okay. Now we will go to 6 bar. The next one is 6 bar. Means six-fold rotation plus inversion. Six-fold rotation plus inversion. Six-fold rotation means in 360 degree we have 6 faces That means after each 60-degree rotation we have one, we should have one phase. After each 60-degree rotation we should have one phase, okay, one symmetric phase. But here we are not operating with rotation, we are operating with rotation plus inversion. That means you have to rotate 60 degree and then invert. Okay, so this is the first phase F1. Now if I'll rotate it 60 degree, it will come here, and then we have to invert, it will come here. If I'll rotate it, it will come at this position, so it will become F2 dash. Now from F2 dash it will invert, so it will become F2, the back side. In the lower hemisphere and in the back side it will become F2. This is F2 dash, and F2 dash means because we got it in rotation, then we have to invert, so it will become second phase. Now again we have to rotate 60 degree. This is F3 dash, and then we will invert, it will come here F3. Then if we will rotate 3, it will become F4 dash, and then we have to invert, so it will come here 4. So if 3 will be rotated, it will come here, and then inversion phase will come here. This is the fourth phase. Then again if we will rotate 4, it will come here. This is the position of F5 dash. Then we have to invert it. This is the rotation of fourth phase, so F5 dash, and then inversion. So this is the fifth. Again if we will rotate 5, it will come here. Inversion phase will come at this position. This is the rotation phase, F6 dash, and then it inverted here. If we will invert it, it will come at this position. This is sixth. Okay, we'll go back to the initial one again. So here this is the first phase F1. What we have to do is we have to rotate and then invert. This will become second phase. Now what we have to do? Rotate and invert. So it will come here. Then rotate. See this position become brighter. Okay. From 3 it came here, rotation phase. Then inversion here. From 4 we'll rotate and invert. It will become 5. From 5 we'll rotate. See here, this is the rotation one. This one is the rotation one, and then we'll invert, it will become the sixth. Now if we'll rotate the 6, it will come here, and if we'll invert it, it will come to the first phase. If we'll rotate the sixth phase, it will come at this position, and then it will invert to first. Okay. So because we are reaching the initial phase, we have to stop our mission here. So the final structure is like this: above 3 faces, below 3 faces, and each faces is having a symmetric phase below. That means first is here. Suppose these are 3 faces, first, second and third. Here this is fourth, fifth and sixth. So below 1 there is fourth phase, below 2 there is fifth phase, below 3 there is sixth phase. So below each phase there are symmetric phases. In the upper hemisphere we have 3 phases, in the lower hemisphere we have 3 phases, and below each phase we have symmetric phases. So here we are also having one mirror plane here, perpendicular to the roto-inversion axis. We are having one mirror plane. One mirror plane is passing. Because the rotation axis is vertical, the mirror plane is horizontal. So now we have 3 faces above and 3 faces below, and in between there is a mirror plane. Perpendicular to the rotation axis there is a mirror plane. Because in the upper hemisphere we are getting 3 faces, lower hemisphere we are getting 3 faces, So now this six-fold is reduced to threefold. The six-fold rotation reduced to threefold, because in the upper hemisphere we are having only three faces. When we are rotating the axis, we are only getting three faces, one here, and one here. So in 120 degree we are getting one face. So now six-fold is reduced to threefold, and there is a perpendicular mirror, So the 6 bar became 3 by m. Why it became 3 by m? Because six-fold rotation reduced to threefold rotation, and there is a horizontal mirror which is perpendicular to the rotation axis. So 6 bar we can write as 3 by m. So 6 bar is reduced to threefold rotation axis, and there is a mirror plane perpendicular to it. Okay, 2 bar will reduce to mirror plane, 6 bar will reduce to threefold rotation axis and one perpendicular mirror. When we'll take 1 bar, it will become two faces. When we'll take 3 bar, it will become six faces. When we'll take 2 bar, it will become m. When we'll take 6 bar, it will become 3 by m. And 4 bar is a disphenoidal class. Here also we have two faces. When we take 4 bar, there also we have two faces, but here there is no mirror plane. 4 bar is not equal to 2 by m. Why there is no mirror plane? Because this face is not having a symmetric face below, right? This F1 is not having a symmetric face below. Exactly below it there is no symmetric face. Similarly, this face is not having a symmetric face just above it. In 6 bar we have, but in 4 bar we don't have that. We don't have symmetric face one above other. So 4 bar is reduced to 2. 4 bar is reduced to twofold, because we have taken 4 bar means we should have symmetric faces in 90-degree rotation. But here we got only two faces. In 360 degree we should get four faces, but we got two faces in 360 degree rotation. In one complete rotation in 360 degree we will get only two faces. So 4 bar means it is reduced to two faces, twofold, it is reduced to twofold, but there is no mirror plane here. But in 6 bar we have, but in 6 bar it will be reduced to 3 by m. It will be reduced to threefold, and there is a perpendicular mirror. This is called trigonal dipyramid. Trigonal dipyramid. You can ask why it is trigonal. We have taken six-fold rotation. Why it is trigonal? Because it became threefold, because it is reduced to threefold rotation. So it will become trigonal, and it will become dipyramid. Why it is becoming dipyramid? When three or four faces meet together, they are called pyramid. When three or four faces like this, if there are three or four faces meeting together, it is called pyramid. So you all know what is a pyramid, right? So if three or four faces meeting together in one hemisphere, they are called pyramid. Now above there is a pyramid and below there is a pyramid, like this. Below there is a pyramid, so it will become dipyramid. Now here I have shown fourfold, means four faces above and four faces below, but here we have three faces above and three faces below. So above there is a trigonal pyramid, this part is a trigonal pyramid, and bottom one is a trigonal pyramid. So it is trigonal dipyramid. Both the hemisphere will have two pyramids, upper pyramid and lower pyramid. So trigonal dipyramid. In this example, 6 bar. Okay, this is the trigonal dipyramid. Okay, so we read all rotational symmetry, we read center of symmetry, we read mirror plane symmetry, and we read all the roto-inversion symmetry. Okay, so from the next video onwards we'll start the 32 classes, and I will explain each classes elaborately. Okay, thank you.